Hey guys, today's lesson is over one-step equations and one-step inequalities and solving for them. So we're going to start with this idea of opposites, something that you have been doing for your entire life and something that you know really well. Light and dark, opposites. Hot, cold, stop, go, big, small. We don't normally think of opposites in math, but we do have them. We call opposites in math inverse operations. Well, what are inverse operations? Inverse operations are two operations, like addition, subtraction, multiplication, division, that undo one another. Take a moment, see if you can think of any inverse operations in math. The inverse operations that we're going to be focusing on today are addition, which goes along with subtraction, and multiplication that goes along with division. There are other inverse operations that we're going to see later down the road, like when you square the number and then take the square root. But for today, we're going to focus on the basics: addition and subtraction together, multiplication and division together. So does this ever happen in the real world where operations have to undo one another? It happens all the time without us really even thinking about it. So let's say we're going to a grocery store. We want to buy an apple for $3, cheese for $4, a donut for $1, ice cream for $2, and a whole cake for $10. You get to the checkout line, you add up, find the sum of all of your items, and it costs $20. You're lucky, no tax today. All right, but you don't have $20, all right? So we need to undo all of this addition that just took place. We need our bill to be lowered, all right? So it's obvious the ones that we're going to throw out, all right? We're gonna get rid of the apple and the cheese. So if we take these two items off of our bill, in order to undo that, we subtract. So we take off the $3, and then we take off the $4 to get our bill lowered to $13. So when are we going to ever use this in algebra? We're going to need to do this in order to solve equations. When we solve equations, our goal is to isolate the variable. Usually we think of a variable as x, but it can be any letter. So my job is to isolate x, to get it all by itself. In order to do that, I need to move this 3 that's being subtracted to it to the other side. Well, we just learned about inverse operations, and I know to undo subtracting 3, I'm going to add 3. And what I do to one side, I'm going to balance it out by adding 3 to the other. Our inverse operations undo one another, so I'm left with x is equal to -2. My y is located on the right-hand side. However, I'm going to solve the same way. I have the same goal. I want to isolate y to get it all by itself. So right now, 2.8 or 2 8/10 is being added on to y. I need to isolate, so I need to do the inverse operation. The opposite of addition is subtraction. So I subtract 2.8. That will undo one another, and since I need to balance my equation, I subtract 2.8 from the other side as well. So we have 0.9 minus 2.8, or 2 8/10, and that is -1.8, which is the same as saying y equals -1 8/10. Y is allowed to be on either side. We're going to move on and continue. This time we're going to look at multiplication and division. Remember, When a decimal or a number is right beside a variable, that represents multiplication. So in order to isolate the r, to get it all by itself, I need to use the inverse operation, undo one another. So since 2.5 is multiplying r, I'm going to do the opposite and divide. That way it undoes itself. Balance the equation. What you do to one side, you do to the other. So that cancels or one's out. And r is equal to 75 divided by 2.5, which is 30. This next example is very tricky for students, mainly because of the notation. When we have m with the fraction bar over 5, this represents division. Alright, so we need to use the inverse operation of division, which is multiplication. So I'm going to multiply each side by 5. That undoes one another, so I'm left with m, and negative 4 times 5 is negative 20. This same idea also applies to inequalities. Inequalities are the less than or equal to, greater than or equal to statements. You might remember them from elementary school as Pac-Mans or alligators, the ones. All right, so in solving, the goal is still the same. You want to isolate the variable. Since 5 is being subtracted from x, I'm going to use the inverse operation and add 5. Same idea, we have to balance. So what I do to one side, I'm going to also do to the other. My 5's undo one another, and I'm left with x is less than 2. Alright, even with addition, we're still working with inverse operations. I want to isolate the x. Since 2 is being added onto the x, I'm going to use the inverse operation and subtract 2 from both sides. Negative 5.2 minus 2 is negative 7.2. Is greater than, my symbol just drops down, I keep it the same, x. I like to write my final inequality with the x out in front, so I like to read it in terms of x. So x is less than negative 7.2. Both are the same and they have the same meaning, so they would both be considered correct. Addition or multiplication and division follows the same. Alright, remember this fraction bar, which trips students up, means division. The opposite of dividing by 4 is multiplying by 4. That way the 4's undo one another. Negative 4 times 4 is negative 16. The symbol simply drops down and I'm left with x. I'm going to rewrite that just because I like to. X is less than negative 16. Remember, a number right beside a letter means multiplication. So I need to do the inverse operation and divide. Balance, so I divide both sides. Our inverse operations undo one another, and I'm left with n is greater than or equal to, since it simply drops down, negative 7. All right, we have one last concept that we need to go over, and this is a big concept, big idea that trips students up. When we are involving negatives, when we multiply or divide by a negative, there is a special rule. And that special rule is that the inequality turns around or it flips. So same idea, same principles to start. I'm dividing by negative 7. Since x is being divided, I need to do the inverse operation and multiply. So I multiply both sides by negative 7. This negative 7 is what is going to cause the inequality to flip. It does not matter if the 3 is positive, negative, a decimal, a fraction, a whole number, all right? The multiplier is the number that determines if the inequality will flip. Since our multiplier is -7, when we write our final answer, the inequality automatically turns around. It flips. So I'm going to continue with my math. 3 times -7 is -21. These -7's undo one another. I like to rewrite. X is greater than -21. Last example. My goal is to isolate M. A number beside a letter is multiplication. I do have to be wary because I'm dealing with a negative. So I'm going to divide each side by -5. The number that is dividing is negative, so I know my inequality